Have you ever wondered what the heck is a rag? If so, stick around because we are about to de-jargonize this for you.
It sounds technical, but it's a powerful technique that's becoming central to how many AI tools work, especially in business.
So what is it exactly? How does it work?
In general, RAG is a technique that improves the answers of large language models by letting them look up information from an external source before they respond.
Okay, so instead of the AI just relying on what it already knows from its training data, it does a quick bit of research first.
Exactly. The system fetches relevant documents at the moment a question is asked and uses them to ground its answer in facts.
I like that term, ground its answer. It suggests a more factual, reliable response.
It is. The model still writes the reply in a natural, conversational way, but the actual substance of the answer is pulled from a specific body of knowledge you provide.
Is there an analogy that can help us visualize this?
There's a great one. Think of a knowledgeable consultant. Before they answer a client's question, they don't just rely on memory.
What do they do instead?
They step over to a filing cabinet, pull the 3 or 4 folders most relevant to the question, read them, and then draft a reply based on what those folders say.
That makes perfect sense. The consultant's general expertise is still in their head, but the specific, crucial details come directly from those files.
Precisely. RAG gives a language model that same filing cabinet habit. It's a way to connect its general abilities to specific, trusted information.
So let's look under the hood. How does the AI actually use that filing cabinet? It must be an incredibly efficient process.
It is, and it generally follows a 4-step process. It all starts with a step called indexing.
Indexing? That sounds like organizing the library before anyone can borrow a book.
That's a great way to think about it. A collection of documents, say internal company articles, is broken down into smaller chunks. These chunks are then converted into numerical representations called embeddings.
What do these embeddings do?
They capture the meaning of the text, not just specific keywords. All of these embeddings are then stored in a special database designed for what's called a similarity search.
Okay, so the library is organized. What's the second step when a question comes in?
That's the retrieval step. When a user asks a question, that question is also turned into an embedding. The system then searches the database to find the chunks of text that are closest in meaning to the question.
So it's a super fast search engine that works on meaning, not just matching words. Once it finds the right documents, what's next?
The third step is augmentation. Those retrieved chunks of information are inserted directly into the prompt that gets sent to the language model, right alongside the original question.
So it's like handing the model a briefing sheet with the specific facts it needs to answer correctly.
Exactly, and that leads to the final step, generation. The language model then writes its answer using the material it was just given as its primary source of information.
That's a fascinating process. It almost sounds like you're giving the model a crash course on a new topic with every question.
That's a good way to put it, but it also leads us to a common misconception about how RAG works.
What's that?
Many people assume that RAG is permanently teaching the model new facts or updating its core knowledge, but it isn't.
So the model isn't actually learning from these documents in the long run.
No, it's not. The model's underlying programming and the data it was trained on are not changed at all. RAG is more like handing the model fresh notes at the moment of the question, like passing a briefing sheet across a desk.
Ah, so once the task is done, the notes are essentially thrown away. The model doesn't retain that new information for the next question.
Exactly. If you close the session, the model retains nothing new. It's a temporary, in-the-moment enhancement, not a permanent upgrade to its memory.
That also implies a potential weakness. If the system is so dependent on the documents it retrieves for that one task, what happens if it pulls the wrong ones?
That's a crucial point.
A RAG system can still produce wrong answers. If that initial retrieval step fails to find the correct documents or misses the most relevant ones, the model will be working from a flawed set of notes.
So, despite that potential weakness, the importance of this technique can't be overstated, can it?
Not at all. When you ask why RAG matters, it really comes down to practicality. It is the main method for connecting general purpose language models to private, current, or specialized information.
And it does this without needing to retrain the models, which I assume is a huge undertaking.
It is. Retraining is incredibly expensive and complex. RAG is the game changer because it sidesteps that, making it central to most enterprise AI applications we see today.
Can you give some examples of where it's being used?
Certainly. It's the engine behind many internal AI assistants that can answer employee questions about company policies. It also powers advanced internal search tools that can find information in a company's wiki or research papers.
I would imagine customer support is another major area.
Absolutely. Many of the customer support bots in use today are built on RAG. They can provide accurate answers by pulling information directly from support articles in real time.
So, to sum it all up, RAG is essentially the key technology that allows businesses to build tailored, accurate, and helpful AI applications.
That's it, exactly. It's what allows them to harness the power of large language models and connect them securely to their own proprietary information.